So today we're talking about shifts in equilibrium. When we're talking about which way equilibrium is going to shift, we're talking about Le Chatelier's principle. Le Chatelier's principle states that if a change is imposed on a system at equilibrium, the position of the equilibrium will shift in a direction that tends to reduce that change. So we need to predict the shift in equilibrium of these additions or removals. So we have our equation, and make sure that you pay attention to solids and liquids. The first thing, if it's talking anything about equilibrium, always look for solids and liquids and cross them out. If you don't, you're going to mess up on quizzes, tests, and worksheets. So if I add carbon monoxide, in order to reduce that change, I'm going to have the reaction use that carbon monoxide up by shifting to the left. So when I add something, I want to get rid of it. If I'm adding As4O6, it's a solid, which isn't part of the equilibrium expression. So there's no shift with that. As well as if I remove it, again, it's not part of the equilibrium expression, so there's no shift. If I remove As4, I'm going to want to make that As4 back up, so I shift to the right to reestablish equilibrium. So when I remove something, it shifts in the direction of that removal. When you add something, it shifts in the opposite direction. There's three ways that you can change the pressure in a reaction. First is add or remove a gaseous reactant or product. If you add an inert gas, which is not involved in the reaction, it changes the pressure, or if you change the volume of the container. If I do those things, these are the effects. If I add or remove a gaseous reactant or product, then it's going to shift equilibrium to either the right or left, depending on if I added a reactant or product. If I add an inert gas, then there's going to be no change, because inert means that it's not in the equilibrium expression. And finally, if I change the volume of the container, I need to think what happened to the pressure. If I have a smaller volume, I want less gas to reestablish the pressure. So anytime it says increase pressure or decrease volume, I'm going to shift in the direction of less gas. If it says increase volume or decrease pressure, I want more gas. So you need to identify which way the volume is going to shift. Which way equilibrium is going to shift if volume is reduced. If volume is reduced, I've got to be thinking, where's less gas? Cross out your solids and liquids. And so I have 6 moles of gas to 0 moles of gas. So if it shifts right, I have less gas. Go in and try the next two on your own. For the second one, we had 1 mole of gas to 2 moles of gas, so it shifts to the right. Again, direction of less gas. And in 3, I have 4 moles of gas in the products and 4 moles of gas as reactants. So if I have equal moles of gas, then it can't shift in either direction because both have the same amount. So when it's 4 to 4, there's going to be no shift. Temperature is the only way to affect the equilibrium constant. Endothermic reactions, equilibrium shifts to the right and K will increase. You don't really need to remember that, except you need to remember endo and exo and where energy is. If it's an endothermic reaction, energy is a reactant. And remember, your delta H would be positive. If it's an exothermic reaction, then delta H is negative and energy is a product. So because this is an endothermic reaction, energy is a reactant, and then when I increase energy or temperature, it shifts the direction to the right. It's just like increasing A or B. It's going to shift it to the right. When it shifts to the right, I'm going to have more products, which means I'm going to have a higher K. So for each of these, we need to predict how K is changed. So the first one, you need to remember that delta H positive was endothermic. And if it's endothermic, then our energy should be a reactant. Make sure you take the few seconds and write plus energy over there. If temperature is increasing, I'm increasing energy, which is a reactant, so it shifts right. Anytime it shifts right due to a temperature change, then K also increases. For the second one, delta H is negative, meaning that our reaction is exothermic, which means energy is a product. Again, I'm going to write plus energy. I'm adding a product, so it's going to have to shift left to use that product up. If I shift left due to temperature, I'm going to have less products, meaning a smaller K. You have about 10 different situations that you need to determine if it shifts right, left, or no shift. Solve these on your own, and we'll check these in class.